The AWS Cloud Development Kit and CloudFormation, often referred to as CFN, are the two most popular ways to manage AWS resources using infrastructure as code. IAC is the management of cloud infrastructure through code or configuration files rather than manual configuration in the console. The IAC files can be version controlled through Git, which makes tracking changes and deploying to other environments easier. Plus, the ability to code review infrastructure changes is huge. AWS launched the CloudFormation service in 2011 as a way to create or manage resources through IAC. A CloudFormation template is a JSON or YAML file where resources and their configurations are statically defined according to the CloudFormation template specification. When you upload the template to the CloudFormation service, either programmatically or through the console, AWS provisions your template into a CloudFormation stack, which is a set of all the resources you define in the template. It'll then create each of the resources with the configurations you defined. When you later need to make changes, you simply edit your template, upload it to CloudFormation again, and it will make the updates to the stack and its corresponding resources. This is great and all, but if you've ever written CloudFormation templates directly, you'll have quickly realized there are some serious shortcomings. First, you'll understand how hard it is to write these static files without any IntelliSense from an IDE. For example, I'm trying to create an SNS topic and an SQS queue, and then subscribe the queue to the topic. Do you see where the mistake is? Yeah, probably not, and VS Code definitely doesn't either. In this example, the name property for the topic should be topic name, not name. The message retention period for the queue should be a number, not a string. And the reference for the topic ARN won't be found because I defined it as my SNS topic, not SNS topic. Second, there's no good control flow. Let's say I need 10 S3 buckets. To achieve that, I'd need to copy and paste this code 10 times. Third, there's no way to abstract out common patterns and reuse them. What if I need to use this topic to queue pattern again? I'd be stuck constantly rewriting it. And finally, these templates have poor readability. They're hard to understand what's going on and how the resources are connected. Now, the problem isn't actually with the CloudFormation template itself. In fact, they make sense. They're static files that define all the configurations of AWS resources in the stack. The problem is really the way we interact with and create these templates. This is where CDK comes in. It solves the problem by allowing you to define your infrastructure using object-oriented programming, and then it generates the CFN templates for you. Here's how it works. You use the CDK CLI to initialize an app or project in the programming language of your choice. In this app, you declare stacks and the resources inside, called constructs, using classes in the programming language you selected. Then, you use the CDK CLI to synthesize your project, and it'll generate CFN templates as build artifacts. Those CFN templates are then uploaded to the CloudFormation service just like before, and it will create the stacks and provision the resources in your account. When you use CDK, you're still generating CFN templates at the end of the day, but rather than manually writing them in YAML or JSON, you're using constructs to model your resources in the programming language you prefer, and then having CDK build them for you. This new approach solves all the problems from before. I created a new CDK project in TypeScript using the CDK CLI. Although you can configure it to be defined in several programming languages like Java or Python, TypeScript is by far the most common. Here, a new instance of a CDK app is created, and then you'll instantiate new stacks below it. I'll open up the stack, and you can see it's just a class that extends the stack class. Inside the stack, you can add and configure constructs. These constructs are what you use to create resources. If you look at the AWS construct library, there's tons of constructs for each AWS service. For example, if I want to model an S3 bucket, I can look under the S3 section and see the construct for the bucket. It gives an example and lists the props it takes as configurations. You can also see the methods you can call on it, such as add lifecycle rule or grant public access. I'm going to convert the CFN template we looked at before to CDK code. I'll start with importing the constructs I'll need from the CDK library, such as the topic, queue, and subscription. I'll create the topic by creating a new instance and passing in the topic name. Similarly, I'll then create the queue by passing in the queue name and retention period, which I can see needs to be of type duration. And finally, create the subscription by calling the add subscription method on the topic and passing a new SQS subscription instance as a parameter. And that's it. Okay, so going back to the initial problems I mentioned before, let me show you how CDK solves them. First, let's look at the IntelliSense. I changed the CDK code to reflect all the errors we originally had with the CloudFormation template I wrote before, and it's immediately clear where the problems are. The TypeScript compiler calls out that the name is not a valid property for the topic, so I'll change it to topic name. For the queue, it says the retention period should be of type duration, not string. And finally, when I reference the queue by the wrong variable name, it says it can't be found. Second issue was the control flow. If I wanted a bucket duplicated in CloudFormation, I was stuck copying and pasting. But in CDK, I can use a for loop to create multiple buckets. Here, I'm creating a loop from 0 to 10, and then instantiating a new bucket, passing the index value into the bucket name so that each bucket is unique. Third, remember I said, what if I want to reuse the topic to queue pattern again? Well, I can actually create my own construct. I'll start by creating a new file to define it in. I then create a class that extends construct. I'll need to define an interface that holds the configuration props, such as the topic and queue name, for my custom construct. In the constructor, I'll pass in the scope, ID, and props. Now I can move the topic, queue, and subscription into the new construct. I'll set the name for the queue and topic from the props, and that's it. Back in my main stack, I can use this custom construct by creating a new instance of it. I'll say new topic queue construct, give it a topic and queue name from the props I defined, and then it's done. Custom constructs make it really easy to reuse patterns and create custom configurations. These custom constructs can then be used across projects or shared with others. And the last point was about readability. You can step back and really see how much clearer this is. The resources are much easier to organize, and the relation to one another is easier to understand. When I'm ready to build the templates, I can run CDK synth from the CLI, and it'll build all the CFN templates. I can also run CDK deploy, and it'll deploy the templates to CloudFormation. This really just scratches the surface of what you can do with CDK and CloudFormation, but I hope it conveys how powerful these tools are. Having the ability to model all your infrastructure from networking, compute, storage, database, access controls, policies, and more in an object-oriented programming language lets you quickly build and deploy complex architectures. Plus, CDK and CloudFormation are completely free. You only pay for the resources that are created as you normally would. If you found this video helpful, please give it a like and subscribe. If you have any ideas for future videos, leave a comment below. Thanks.